This is lecture 6, part 1, for systems thinking and analysis, and also introduction to systems engineering. And in this lecture, we're going to focus on the concept exploration for systems engineering. The material discussed in this lecture is also available in your textbook. If you look at chapter 7 in the Systems Engineering Principles and Practice textbook for this class. The agenda for today includes the following three topics. First, we're going to talk about developing the system requirements. Two, we're going to talk about the operational requirements analysis. And finally, we're going to discuss the performance requirements formulation for your system. So let's start with developing the system's requirements. The process of need analysis, which is what we discussed in our previous lecture, is intended to provide a well-documented justification for initiating the development of a new system. So we go through that process in order to understand the need, and in addition to that, find a justification for developing a new system based on that need. The process also produces a set of operational requirements or objectives that describe what the new system must be designed to do. Okay, so we have these objectives. Basically, these are the things that the system, or what we are proposing with this analysis, is supposed to achieve. These are the operational requirements. So after going through the process of defining, justifying the system, and also defining the objectives of this system, we transition to the concept exploration phase. The principal objective of the concept exploration phase is to convert the operational oriented view of the system derived in the needs analysis phase into an engineering oriented. This conversion is necessary to provide an explicit and quantifiable basis for selecting an acceptable functional and physical system concept. So the idea now is going from this need, going from understanding the objectives, the needs of the customer, we want to do a transition in which we can define an engineered version of a system that will be able to meet those needs or those objectives. Here's where we transition to define the functions that the system must perform in order to achieve those objectives, and also the technology that will be needed in order for the system to achieve those objectives. So the place of concept exploration phase in the system lifecycle, if you remember, the concept exploration is just after the needs analysis, and it receives as an input the system operational effectiveness and the system capabilities. From here, we're going to transition to the concept definition, in which we are going to provide some candidate system concepts and also specify the system performance requirements for the concept definition. So the focus is on the development of performance requirements that accurately state the customer needs. In terms of the system materialization status, the needs analysis phase was devoted to defining a valid set of operational objectives to be achieved by the new system. Basically, to demonstrate that there was at least one possible way to meet the projected need. Thus, in the concept exploration phase, one starts with a vision based generally on the above feasible concept. The degree of the system materialization addressed in this phase has progressed to the next level, namely the definition of the functions that the system and its subsystem must perform. As I mentioned in the previous slide, we are now transitioning to defining functions that are going to be used to meet the objectives of the system. Also, by specifying these functions, we are going to try to link some type of technology that will allow us to implement those functions. And into the visualization of the system component configuration as illustrated in table 7.1, which is in the next slide. So if we look at the concept development or the status of the system materialization of the concept exploration phase, we are in the second column in this, well, actually the third column, but the second column under the concept development phase. We have the concept exploration, and we can see at the system level, we are identifying, exploring, and synthesizing concepts. At the subsystem level, we are going to define requirements and ensure feasibility. And at the subcomponent level, we are going to start visualizing what are the technology that we will need in order to develop this concept. So here's where we are. The systems engineering method in the concept exploration. The activities in the concept exploration phase and their interrelationships are the result of the application of the systems engineering method. So we go through this step by step. We're going to start with the operational requirement analysis or requirement analysis. And typical activities includes analyzing the stated operational requirements in terms of their objectives and restating it or amplifying to provide specificity, independence, and consistency among different objectives to ensure compatibility with the other related systems and to provide such other information as may be needed for completeness. So that's what we are going to be performing at this in this first step of the systems engineering method. After that, we focus on the performance requirements formulation or the functional definition. Okay, so we stated the objectives. Now we are trying to build these functions that will allow to the system to perform the objectives that were stated. So translating operational requirements into system and subsystem functions and formulating the performance parameters required to meet the stated operational requirements. Okay, so what are the parameters? These are the quantities that you are going to use to measure the performance of your system. So if you're looking at the car, mileage per gallon in terms of fuel consumption could be a parameter that you are going to use to measure the performance. So we had to formulate the performance parameters required to meet the stated operational requirements. Next, we go to the implementation concept exploration, which is the physical definition, and typical activities includes exploring a range of feasible implementation technologies and concepts offering a variety of potentially advantageous options. So here we can use existing technology. Let's say your system requires some type of location device. We can use GPS technology to address those. If there's a need for, I don't know, some type of algorithm to be run, there's a computer that you can use, which is an existing technology. But at the same time, there might be technology that doesn't exist or technology that haven't been tested that we might want to incorporate in our system. Things like, I don't know, a different type of engine, let's say using hydrogen, and so on. So here's where we look at feasible implementation technologies that can be used to achieve the purpose or to implement the system functions that you specify in the previous step. Developing functional descriptions and identifying the associated system components for the most promising cases, and defining a necessary and sufficient set of performance characteristics reflecting the function essential to meeting the system operational requirements. The systems engineering method, again, that's what we are discussing in concept exploration. We transition to the performance requirement validation or design validation, and typical activities includes conducting effectiveness analysis to define a set of performance requirements that accommodate the full range of desirable system concepts. So conducting effectiveness analysis to define a set of performance requirements that can accommodate the full range of desirable concepts. So here we are trying to basically, through experimentation, where we are trying to define these bounds that are typically met by most of the concepts that we are going to be proposing. So for instance, if you're looking at designing a hospital, you are going to look at certain characteristics that are typical in most hospital facilities. Let's say we have an emergency room that can accommodate 200 beds or 100 beds, or a range between 100 and 200 beds. Or we have, I don't know, we're designing a school, and the school might be able to hold, I don't know, students from kindergarten to 5th grade. So those are performance requirements for your system that can accommodate the full range of desirable system concepts. Validating the conformity of these requirements with the stated operational objectives, and refining the requirements if necessary. The interrelationships among these activities in the above steps in the systems engineering method are depicted in the flow diagram on the next slide. So I like this diagram because it shows the relationship between the 4 steps of the systems engineering. I'm sorry, the 4 steps on the systems engineering method in the concept exploration. So you see at the top, you have the needs analysis phase, which is what we transition from. And then we go through the 4 steps, right? The operational requirement analysis, the performance requirements formulation, implementation, concept exploration, and performance requirement validation within the concept exploration. So this is a good diagram in terms of highlighting the most important aspects of the systems engineering method in this particular phase of the system lifecycle model. Okay, so let's transition to the next slide. So next, we're going to talk about the operational requirements analysis. And in here, I'm going to use this figure, which depicts the general process of developing requirements. So we have discussed formulation of requirements in some of the previous lectures, and writing requirements as well. So now we're going to go deeper into this topic. So operational requirements analysis, the general process for developing requirements. You start with requirement elicitation, then the analysis, validation, and then also documentation. If you look at the figure or the flow chart, you look at requirement validation, there's a feedback loop there in which if you cannot validate, right, you can go back to the analysis and refine. And from there, you can go back to validation, or you can go straight to requirements documentation, which is the final step. So the first activity involves the creation of a set of requirements. If in the concept exploration phase, a set of operational needs and requirements has been established. This must be translated into a set of system-specific requirements describing its performance. So in terms of requirement elicitation, when analysts are developing operational requirements, they rely heavily on input from users and operators, typically through market surveys and interviews. When analysts are developing performance requirements, they rely on both people and studies. Initially, the customer or buying agent within an organization is able to provide thresholds of affordability and levels of performance that are desirable for the system that you are trying to design. But subject matter experts can also provide performance parameters as a function of technology levels, cost, and manufacturability. Okay, so these 2 points of views are important to keep in mind when doing the requirement elicitation. A useful approach to developing requirements of any type is to ask the 6 interrogatives: who, what, where, why, when, and how. The operational requirements focus on the why, defining the objectives and purpose of the system. The performance requirements focus on the what, defining what the system should do and how well. In terms of requirement analysis, this activity starts with an initial set of requirements from the elicitation state. Individual requirements as well as the set of as a whole are analyzed for various attributes and characteristics. Some characteristics are desirable, such as feasible and verifiable. Other characteristics are not, such as vague or inconsistent. For each requirement, a set of tests or questions is applied to determine whether the requirement is valid. These tests are specific to the development of system performance requirements. So the first question is the requirement traceable to a user need or operational requirement? The second is the requirement redundant with any other requirement? And the third question is the requirement consistent with other requirements? Requirements should not contradict each other or force the engineer to any feasible solution. So these 3 questions, in addition to the next that we're going to see on the next slide, can help you analyze and validate your requirements. Number 4, is the requirement unambiguous or not subject to interpretation? So we want anybody who reads this requirement to be able to understand what we want to transmit with this idea. So if this requirement is read by different people and they have a different understanding of what they need to complete, then that requirement needs to be revised. Is the requirement technologically feasible? Is there a way for us to implement the function or the threshold or to achieve that threshold that is required? So for instance, you want to design a car that can, I don't know, pull a school bus, but then you want to use an engine that doesn't consume as much gasoline. So is there any technology, maybe electrical car, we don't know, that we can pull this up in terms of making it technologically feasible? Another example could be we want to develop a car that can fly. Is that something that is feasible? There's no technology right now that we can use for those purposes. So on. Is the requirement affordable? Is the money that we have available, the resources that we have available, sufficient in order to achieve that requirement? Do we have enough time? And so on. Is the requirement verifiable? Is there a way for us to make sure that this requirement is satisfied when we are testing our concepts? If the answer to any of these questions above is no, then the requirement needs to be revised or possibly omitted. If, in addition, other requirements may need to be revised after performing these tests. In addition to individual requirements tests, a collective set of tests is also performed, usually after the individual test has been performed on each requirement. So for example, the first question that we can ask in terms of looking at the collective set of tests is, does the set of requirements cover all of the user needs and operational requirements? Second question is the set of requirements feasible in terms of cost, schedule, and technology? And the third requirement is, can the set of requirements be verified as a whole? Both type of tests may need to be iterated before a final set of performance requirements exists. Okay, so I'm going to stop at this point, and then on the next lecture, we are going to continue our discussion on the concept exploration.